Okay, we're going. So let's go through the questions in this booklet that we did not go over yesterday. So yesterday's video, or yesterday's lesson, we did problem 1. We did problem 2. So now we're on problem 3. Can everybody take a look at problem 3? So problem number 3, a tank can be filled by a pipe in 5 hours, pipe A. Pipe B would take 8 hours if it was by itself. And then there is a drainage hole that if it was full and you opened it up, it would drain the tank in 20 hours. So we're going to define our variable. We'll let x equal the time to fill the tank. And again, you have to kind of think of this logically. I won't bother writing it on here, but just think that pipe A can fill the tank in 5 hours. So that means it would do 1/5 of the tank in 1 hour. It would do 2/5 of the tank in 2 hours. It would do 3/5 of the tank in 3 hours, etc., etc. So if I call x the amount of time it takes to fill the tank, pipe A works at that rate. And pipe B, oops, I actually have that upside down. Oh, no, I don't. No, that's right. Pipe B is x over 8. And then here's the part that's different from the last two. The other one's a hole. The other one's a drain. So while these are filling, it's losing, but it's losing it at a very small rate, and it would lose the entire thing in 20, but we make that a subtract. So there we go. There's the question. And of course, all of this equals 1 full tank. So what is the LCD of 8, 5, and 20? I believe it would be 40. So if I times this fraction by 40, I get 8x. If I times this fraction by 40, I get 5x. And if I times this fraction by 40, I get 2x. And then this side is, of course, just 40. So I have 8 and 5 is 13, minus 2 is 11x equals 40. I did make them all over 40. I timed both sides of the equation by 40. Right? That's how LCDs work when you're doing an equation, right? You clear the fractions. The question was, shouldn't they all be over 40? No, I multiplied both sides of the equation by 40. And that leaves me with that. It clears my fractions. Okay, so x is now 40/11ths. Now 40/11ths isn't a particularly great way to keep track of time. It's like, gee, how long is that going to be? Oh, 40/11ths of an hour. Nobody would talk like that. So let's go to a decimal. If you run that through your calculator, you'd get 3.63 hours. Even 0.63 hours isn't really the way us normal people keep track of time. So we would take the 0.63 and we times it by 60, and that would give us around 38. I'll just round it to the nearest whole number. So then I'd make a conclusion statement. Therefore, the tank will be full after 3 hours and 38 minutes. And there we go. So there's a tank problem. Next one is another one just the same type. Swimming pool question. So just change that. Okay. All right, so here's problem number 4. Swimming pool can be filled by pipe A in 3 hours and in pipe B in 6 hours, with each pump working on its own. At 9 a.m., pump A is started. At what time will the swimming pool be filled if pump B started at 10 a.m.? So this one has a complication that the last 3 didn't have. The pumps don't all start working at the same time. So I am going to say, here's my let statement. Pump A will work for X hours. So there's what my X is going to be. It's going to be pump A. So that means pump B I should put an S on that, works for 1 hour less. How do you say 1 hour less than X? Yeah, you'd make that X minus 1. And there, that's my let statement. So that's how that's going to work. So pump A, whatever the time is, it does 1/3 of the job in that time, right? Because it works at a rate of 3. And pump B would be X minus 1 over 6. And again, all of that has to equal one full pool. So that's where the 1 comes from. My common denominator here is 6. So I'd have 2x when I multiply that by 6. And x minus 1 when I multiply that by 6. So that's going to be 3x equals 2. Or wait a minute. Hang on, I forgot to multiply this guy by 6. That's better. 3x equals 7. Thank you. And so x is equal to 7/3. So 7/3 of an hour is 2 1/3 hours. And that one I don't need a calculator for. I know 1/3 of an hour is 20 minutes. So therefore, the pool will be full. Now, if I were to just say that my conclusion is the pool will be full in 2 hours and 20 minutes, I think I'd lose half a mark. How come? Yeah, it doesn't say how much time. It says what time. And it gave me a starting time, right? It started at 9 a.m. So 9 a.m. is the x, or right, the first one, so x, and then when you add 2 1/3, so that would be at 11:20 a.m. There we go. So that's problem 4. All right, and that's it for pump questions. We have a question.
How do you know they equal 1? Just because there's one pump?
That's the way, yeah, that's the way all of these problems work, right? You're splitting up a job. The question was, how do you always know that the other side of the equation is a 1? You'll notice that all of the 4 problems of this set kind of all work like that. And that's because that's how the fractions are being kind of kept here, right? We're breaking up a single job into this element of the job does this fraction, and the other element of the job does that fraction. Well, the fractions have to add up to a complete job, hence one whole. So there we go. So you might see a question like that one. You might see a question like this one. So the other type of kind of problem we've zoomed in on here is ones involving speed and distance and time. Okay, did we do this one yesterday? We did the second one. Okay, so we'll skip. Yeah, right. Now I remember. We did the Mr. Johnson one yesterday. So we haven't touched this one yet. So let's make a little chart for this one. We have a car. We have a plane. Doesn't seem like a fair fight having a race between these guys. And then we have distance. I don't know that I need this line to be this long. Oops. Oh.
When do we use v
then? Okay, so distance, speed, time. All right, so now, what do we know in this problem? The speed of the plane is 7 times as great as the speed of the car. So I think I'll let the car be v, and the plane will be just 7v. All right? Now, they both are traveling 315 kilometers. So that's the same for both of them. And remember that if speed is distance divided by time, then time is distance divided by speed. So that means I can figure out that the time here is v over 315, and this one is 7v over 315. Oh, wait a minute, I got that upside down. Let me start that over. 315 over v, and 315 over 7v. And how do I link these two times together? Well, it says the car takes 3 hours longer than the plane. So to make these two times the same, take the plane, the one that goes faster, and add 3 hours to it, and that would equal the car. Oh yeah, I used v not x, thank you. If you wanted to minus the 3 on the other side to make them two equal, notice that's the same equation. It wouldn't be any different. So that's how I set this guy up.
The car takes longer. Shouldn't the car?
No, yeah, the car takes longer. So to make them equal, add 3 hours to the plane side or minus 3 from the car side. It'd be the same equation either way, right?
So you added more to the car side, right?
No, I added more to the plane side. Because they have to be equal. Remember, what does this symbol mean? It means equal.
Oh, okay.
So to make them the same, think of them as sitting on a teeter-totter where you're putting time, and time is in blocks. Don't you have to add more blocks to the plane side to make it balance? Otherwise the car would tip it over. That's probably more physical than you wanted to think about. All right, let's see. Let's get these things out of the way. All right, I think we're ready to solve. The common denominator is 7v. So I'm going to times 315 over v by 7v. The v's will cancel, and I'll get 2,205. Then I'll times this one by 7v, which would actually end up just being 315. And then this one's going to be 21v. That's a nice, easy equation to solve. So I minus 315 from both sides, divide both sides by 21. I already did the math on this. I know that it's 90. You can use a calculator for a question like this. So now, it says find the speed of the plane and the speed of the car. So I would say, therefore, the car is 90 kilometers per hour.
How did you get 90 so quickly?
Because I already did the calculation with my calculator earlier. And the plane is 7 times that, which is, that's a jet. 630 kilometers an hour.
That is fast.
Now that ain't your little hobby Cessna there. That's a fighter jet. All right. Any questions on how I did that?
Not this one. Do you have like the answer key with the word
Yep.
online?
The question that the microphone's probably not picking up is, do I have the answer key online? And yes, if you check today's blog post, this whole booklet's key is now on there.
Are you recording this?
Yep. It probably won't. The microphone probably won't even pick you up from there. This thing has like about a 5-6 foot radius, and then it doesn't pick up much. All right, next. Okay, I don't think we did this one the other day, did we? Okay, so Timmy left Pacific Rim National Park at 8 a.m. and drove towards Victoria at 85 kilometers an hour. Jimmy left the park an hour later and drove along the same route at 100 kilometers an hour. What time did Jimmy catch up to Timmy or overtake? So I have Jimmy and Timmy. And I have, again, speed, distance, and time. All right, so we know the speeds. They give them to us. Jimmy's 100 kilometers an hour. Timmy's 85 kilometers an hour. Now, distance we actually don't know. But time, of course, is, okay, I think it says at what time of day, so what time. So I'll let time be the x here. But Timmy, I'll make x, and Jimmy is 1 hour less, so we'll take 1 away from Jimmy. Okay? Jimmy left the park the hour later, so he drives for 1 hour less than Timmy does. Okay? Okay, so now, again, speed is equal, or I guess I'm using velocity, not s for speed. Velocity equals distance over time. So distance is velocity times time. So this one doesn't even need fractions. But it's going to be 100 times x minus 1 and 85 times x, right? Because it's velocity times time. And what do I know about those two distances? Well, if one of them's caught up to the other, the distances have to be equal. So there we go. So now I'm going to expand that bracket. 100x minus 100 equals 85x. I'm going to subtract 85x from both sides and add 100 to both sides. And then x is going to be 100/15ths. That simplifies down to, what does that simplify down to? 5 goes into the top 20 times and into the bottom 3 times. So that's 6 2/3. So at what time of day, I'll say, therefore, Jimmy overtakes Timmy at 6 hours, and that'd be 2/3. 2/3 of an hour would be 40 minutes. So we started at 8 a.m. So what's 8 a.m. plus 6 hours? That's 1,400 hours if you'd like to go with military time, but I guess that's 2 p.m. So at 2:40 p.m. Okay, questions?
Didn't Jimmy start an hour later, so is it a +1?
No, that would be if I wanted to know how long. So the question was, wouldn't I have to +1? No, I can do it this way, as long. But remember that x then, if I did +1, that x would represent when Jimmy left. And I thought it was, since they tell me Timmy left at 8 a.m., I thought it was smarter to make Timmy the x, so that I know I don't have to do any changes to the x to go directly to the time.
So you're making them leave at the same time?
Well, yeah, this kind of balances the time, right, by taking one away. But the fact that the time is again linked to this person is why I made that one the x. So instead of doing this one as an x plus 1, which would have solved the equation, but then I would have had to remember to take 1 hour away for the clock time. But I didn't have to do that since I made this one the x.
Another question. So
Yep.
for like most of these velocity, distance, time questions,
Mhm.
we're given two of the variables, and
Yep.
then we have to solve for the other one, and then we put that into our equation and then solve.
That is true. The question, if you couldn't pick it up on the microphone, is these questions all seem to work the same way, right? You are given one set of things, your variable is the other set of things, and then the third element, whether it's speed or distance or time, is the equivalence that you build your equation on. Yes, that's how all of these work. So, nice job picking up on that pattern. That's about it for the ones I'm going to go through with you in class. You still have a page of them to try, and then there's some extra ones in the textbook if you want more after that. Now we're going to do the very last thing that we do in Chapter 7. I don't think there's any questions like this on the test because I think the regular classes don't do this anymore. It's a very cool topic though, and it's basically just using your algebra skills to solve for variables when you don't necessarily have when you have more than one variable and you don't always have numbers to work with. So take a look at this one. Solve for m. Okay, so how do we solve for m? Well, the first step, I guess, is we're going to multiply both sides of the equation by the LCD. So we're on to the next page here, guys. 15 plus m times 40. And okay, so we're going to multiply both sides of the equation. So the 40s cancel on that side. The 15 plus m's cancel on that side. And I now have 15 plus m times 2a plus 7. So I'm going to have to multiply that out. And that's going to give me 30a plus 15 times 7 is 105. And then this one's going to be a term with two variables in it. 2 times a times m. Doesn't matter what order you put the variables, but I like to go alphabetical. And then m times 7. Unlike usually when you multiply together binomials, if the terms are, you have the same variable and both parts are both binomials, you end up being able to simplify it to a trinomial when you're done, right? Well, in this case, no, none of those are like terms. You cannot add any of these four things together. You're stuck with four terms. Meanwhile, on the other side of the equal sign, you have 40m. Now, your job is to solve for m, right? So that means the smart thing to do here is to get all of the m's on one side of the equation. So I already have two of them on this side, so I'll stick to this side. So 7 minus 40 is negative 33 m's. And then I'll move the things that don't have m's in them to the other side. So that'd be negative 30a minus 105. Now here's the problem. If I'm going to solve for m, I have to isolate it. And right now, it's kind of trapped in these two terms, and I can't add them together. They're not like terms. So I'm going to use my factoring skills. No, I'm not dividing. I'm factoring. I'm going to factor m out. And then my last step, and I'm kind of out of room, so I'll move over here. My last step is now I divide both sides of the equation by 2a minus 33. So m isolated would be negative 30a minus 105 over 2a minus 33. And that's it. That's as simple as you're going to get m.
That makes sense.
All right. Let's do one that has no numbers at all. And this is what folks in the sciences do when they have complicated formulas. They do algebra. Solve for e. Okay, so I need to isolate that e. That one's actually not too hard. I will multiply both sides of the equation by the denominator. So I have c times n times r plus c times r equals n times e. Right? I just multiplied both sides of the equation by this denominator. Then I'm going to divide both sides of the equation by n. So I have c times n times r plus c times r over n. That one was easy. Let's try a tougher one. Same equation. Let's solve it for r. So same equation, but this time I'll solve it for r. So again, the first move has to be the same. I'm going to get c times n times r plus c times r equals n times e. And now we use the same trick we used in the last question. We factor out the r. leaving me c times n plus c. And then we divide both sides of the equation by c n plus c. And I get ne over c times n plus c.
This be on a test. This is like really simple.
I'm glad you think so. The comment we just heard is that, hey, this should be on the test. It's simple. All right, and then this one might be the toughest of the three. What if I wanted to isolate n? Question? Yeah, you could. If you wanted to leave your answer as, the question is it okay to still have brackets? If you wanted to leave your answer as CR times n plus 1 over n, that's the same answer. Okay. Nothing wrong with that either, I suppose. Still the same thing. All right, so now let's try solving this for n. So the first step's still the same. I can't solve for a variable that's trapped in a denominator. So I still have to go c times n times r plus cr equals n times e. But now I have to put the n's together. So c times n times r minus n times e is equal to negative c times r. Factor out my n, and I get c times n, or sorry, I meant to say r. C times r minus e equals negative cr. And n would equal negative c times r over cr minus e. And I'm happy with that as an answer, nothing wrong with it, but sometimes if this is a formula and I have to, plug numbers into it and work with it, having an extra negative around probably makes my life harder. So I might just do this. Factor a negative out of the top and the bottom. And then I have a subtract instead of a subtract and a negative. So I kind of like that one better. And remember that it would be wrong to start canceling like that. Canceling doesn't work that way. All right, so there we go. So that's about it for that. I'm going to hand out a worksheet of this for you to practice on. It's got some formulas for you to move around. And there we go. That's all that's new today. You get some work time.
It's not on the test, though, right?
Nope. I don't think so, anyway. I'll double check. All right, let me just stop what I'm doing here.